Hello and welcome to Okuma's Online Academy. In this lesson, we want to talk about Upthrust and Archimedes' principle. We've mentioned Archimedes' principle briefly when we were talking about relative density, and in this lesson, we want to talk more about Upthrust and relative density. When you place an object in a liquid, there seems to be a force that is acting against the weight of the object. Let's call it U, upthrust. The weight of the object will be going down, and there seems to be a weight or a force that is pushing the object up, that is preventing it from coming more down to the liquid. That is what we call upthrust. So that is why when you place an object in a liquid, you will always observe that the weight of the object is always lesser in the liquid than its weight when it is outside the liquid. That is because of what we call upthrust. The force that is acting against the weight of the object. Acting against it means that if the object weight is going down, the force will be pushing it up. So that is what we call upthrust. So upthrust is actually said to be the weight loss in an object. When you measure the weight of an object in air that is outside a liquid, and you measure its weight inside a liquid like water, you will find out that the weight of the object in air is different from its weight in liquid, and that difference in the weight of the object is what we call upthrust. We can use this upthrust according to Archimedes to determine the relative density of the object by saying that the relative density of the object is equal to the weight in air over weight in water. So if you want to get the relative density of any object, a solid object, what you can do is to just weigh the object in air that is outside water, and then put the object inside water and check its weight again. Then divide the weight you have in air by the weight you have inside water, and that will give you the relative density of the object. For instance, if you are told that an object weighs 10 newton in air and weighs 5 newton in water when fully immersed in water, it weighs 5 newton in water. Now, if we are asked to find the relative density of the object, the relative density is going to be weight in air over weight in water, which is going to be 10 over 5, which is equal to 2. There is no unit for relative density as we have discussed before. So the relative density of the object is going to be 2. So this is how to use upthrust, or the principle of upthrust, to get the relative density of an object. According to Archimedes, he's also saying that the upthrust, or the weight in loss of an object, is equal to the volume of the object displaced. The loss in weight is equal to the weight of the volume displaced. So this actually means that even if you want to get the relative density of a liquid using the principle of upthrust, you can still do that. And how do you do that? You get the liquid you want to measure its relative density, and you get water. You put the object in the liquid. You first of all weigh the object in air and get its weight. Let's say that the weight of the object in air is WA. Then you put the object in the liquid you want to get its relative density. Now let's say that its weight in the liquid is WL, W in weight in liquid, and now you put it again in water. Let's call it WW. This shows the weight of the object in water. Now, the principle of or using the principle of Upthrust to get the relative density will give us that relative density is equal to weight in liquid over weight in water, like we've talked about when we are talking about relative density. Relative density is equal to weight of an object in air in liquid over the weight of the object in water. So the relative density of the liquid now is going to be the loss in weight in that liquid over loss in weight in water. Why? Because the loss in weight in the liquid is equal to the volume of the liquid displaced. It is equal to the volume of the liquid. Why the loss in weight in water is equal to the volume of water displaced. So we can now say that relative density of the liquid is equal to WA minus WL over WA minus WW. So this means weight in air minus weight in liquid over weight in air minus weight in water. This will give us the relative density of the object of the liquid you are looking for. If you want to get the relative density of the object, you weigh it in air and weigh it in water and divide the weight in air by the weight in water. But if you want to get the relative density of a liquid, you get an object, weigh it in air, weigh it again in liquid, and weigh it again in water. Then find the difference in weight of the object in air and that of the liquid, and also the weight of the object in air and that of water. Divide the loss in weight in liquid by loss in weight in water, and that will give you the relative density of the liquid. Now, for instance, if we have that an object weighs 10 Newton in air, a liquid, an object weighs 10 Newton in air and 8.5 Newton in liquid of unknown density, and then 8 Newton in water. This is air, this is liquid, and this is water. Then we may be asked to find the relative density of the liquid. How do we do it? The relative density of this liquid is equal to loss in weight in liquid over loss in weight in water. Loss in weight in liquid over loss in weight in water. How do we get loss in weight in liquid? It is equal to weight in air minus weight in liquid over, how do we get the loss in weight in water? It is weight in air minus weight in water. Now this is equal to weight in air is equal to 10 minus weight in liquid is equal to 8.5 over weight in air is still 10 minus weight in water is 8. Now this is going to give us 1.5 over 2, and that will give us 0.5. This is the relative density of the liquid, 0.75. Now let's look at another example. Let's look at Upthrust. If an object weighs 10 Newton in air and 5 Newton in water, what is the upthrust? If an object weighs 10 Newton in air and 5 Newton in water, what is the upthrust of the object in water? Upthrust, like I said before, is equal to the loss in weight in the liquid. So we just calculate the difference in the weight, which is equal to 10 minus 5, which will give us 5 Newton. So this 5 Newton is the upthrust of the object in water. So this is how to get relative density and how to also calculate the upthrust of an object using the principle of upthrust. So you can see how the upthrust is related to Archimedes' principle and is also related to the relative density of an object. The relative density states that the weight of an object, the weight of a liquid displaced is equal to the loss in weight of an object placed in it. And we can use this loss in weight to get the volume of liquid or the weight of liquid, which we can now use to calculate the relative density of the liquid or the object that we are looking for. So I hope that this lesson is very clear. Thank you.